Hello, this is Professor Kuehn. Welcome back to my lectures on space, time, and motion, where we are discussing Einstein's book, Relativity. You might remember in my last lecture what I did is I introduced you to some of the bizarre consequences of accepting the, first of all, principle of relativity, and secondly, the principle of the constancy of speed of light. Now, what I'd like to do in this lecture is begin talking in a bit more detail about some of these bizarre consequences. The first of them is that the order of events may appear different to observers who are in motion relative to one another. So what I'm going to do is I'm going to draw a few pictures and explain in detail how this arises from accepting those two initial axioms, so to speak. Okay? So take a look at my sketchbook here. Let's talk about the order of events. This will be point 1. Your order of events. I want you to imagine that there are two people riding on a spaceship. So I'm just going to write this out. Suppose two people, I'll call them Matthew and Mark, are on opposite ends of a spaceship. And they place a flash bulb in the middle of the spaceship, so they set it up right in the middle and they walk to opposite ends, so they are equidistant from a flash bulb. A flash bulb at the center of the ship. I'll draw a picture of this. So here would be the ship. And they place a flash bulb right at the center that is going to ignite and create a flash. Okay? And here, let's say, is Matthew at this end. And here is Mark at this end of the ship. Okay? And suppose that they are flying through space at some high velocity, and there is another astronaut out here watching them fly by. And let's call this person John. So according to John, this ship is flying rightward at a very high speed, maybe 20% the speed of light. But of course, from the perspective of Matthew and Mark, they see John flying this way at some high speed. I'll call that speed v. Okay, so this would be from the perspective or within the reference frame of Matthew and Mark, who consider themselves to be at rest. After all, they are an inertial frame of reference. They're moving in a straight line at a constant speed, so they consider themselves to be at rest, and they see John moving by in the other direction at the same speed. Okay? Now, how do they describe this event of the flash bulb going off? Well, they will say that a flash bulb ignites between them. And then what happens is that a moment later, I'll draw this, so this is kind of frame 1, and frame 2 would be a moment later. By frame, I mean think about these kind of pictures at subsequent moments in time, according to Matthew and Mark. The flashbulb had gone off here in the middle a moment ago, and a moment later, the light that has been emitted by the flashbulb, I'll draw this in yellow, arrives at their two locations. There's kind of this sphere of light that goes out. So here's the flashbulb that goes off. A moment later, it has expanded and struck both Matthew and Mark. And since they are equidistant from that flashbulb, the light pulses arrive at their locations at the same moment in time. So the light pulses arrive at their locations, and by there I mean Matthew and Mark's locations, at the same time. That is simultaneously. Okay? There shouldn't be anything too controversial about what I've said so far. Okay? So what is their conclusion? What is the conclusion of Matthew and Mark? We're ignoring John for the moment. He's just outside flying past the spaceship. So what do we say about this? We would say that Matthew and Mark conclude that the two events, here's that word events, so the two events, and what are the events? The two events are light arriving at Matthew and light arriving at Mark, so those are the two events that we're talking about, are simultaneous. Maybe they have each on their wristwatch a light detector, and when it senses a light pulse, it senses light, it stops the stopwatch, and then they get back together and they compare the time at which the light arrived and the exact same amount of time has arrived from when the flashbulb went off and the light arrives at them. Okay? So I don't think there's anything too controversial about what I've said so far. Okay? Now what I want you to do is I want you to think about this same sequence of events, the flashbulb going off, the light arriving at Matthew, and the light arriving at Mark, from the perspective of John outside of the ship. So now, according to John, and by the way, it doesn't have to be a single astronaut outside. It could be a whole host of them, maybe a swarm of astronauts who are all sitting still in space and the spaceship is flying through them. Or, from the perspective of Matthew and Mark, a swarm of astronauts floating in space, flying with the same velocity past them. So according to John and his friends outside the ship, so according to John and his friends outside the ship, who are floating in outer space and see the ship rush by, what do they describe? Well, I'm going to draw a few more pictures here. So first of all, I'm going to draw the ship. Okay, and I have once again Matthew and Mark. And right between them, at some instant, the flashbulb goes off. Okay, and of course, because we're talking about the viewpoint of John, who's floating outside of the ship, he sees the ship flying by at some velocity. Okay, now I'm going to draw a couple of frames here, a few moments in time. So a moment later, John will have seen this ship fly past. It's traveled a small distance, and by that time that it's moved that distance, let's say that's enough time for this light pulse that was centered right here to have advanced enough to hit Matthew in the back of the ship, but not yet hit Mark. Okay, so remember again, there's Matthew in the back of the ship and Mark in the front of the ship. So what are these two frames here? The first one is the flashbulb ignites at some location, and then event 1 happens, is that Matthew detects the light pulse, or it arrives at Matthew. That would be our event 1. And then, a moment later, the ship will have advanced even farther. The light pulse, which had happened, again, right here, the light will have expanded enough to then hit Mark and go past Matthew like this. Okay, and remember, I will just draw John out here who's watching this whole sequence of events. Okay, and of course it could again be several people out here, John and his friends, who are all in this, at rest compared to one another, but watching this ship fly past. So here is when Mark detects the light pulse, and that would be event 2. Now you might see where I'm going with this. So what would John and his friends conclude? Well, according to John and his friends, the two events that we're talking about, the two events occur not simultaneously. They occur not simultaneously. Event 1 occurs first, and event 2 occurs second. Okay? Now, the point that's being made here is that from the perspective of Matthew and Mark, and for that matter, from the perspective of anyone who is at rest with respect to Matthew and Mark in that ship, there are two events happening, the light arriving at Matthew and Mark, and they would all agree that those events happen simultaneously. On the other hand, for John and his friends outside of the ship, who see the light flashing in the middle of the ship, and then the ship moving, they would say that the light arrives at Matthew in the back of the ship before it arrives at Mark in the front of ship. That is, event 1 occurs before event 2. So John and his friends have a different perspective on the order of these two events than Matthew and Mark. Whereas Matthew and Mark saw them occurring simultaneously, John and his friends don't see them occurring simultaneously. They see one occur before the other. Now, there are a few things I want you to notice about this. First of all, it's not some kind of optical illusion that arises because light just takes a certain amount of time to get to John. John, like I said, could have dozens of friends who are astronauts who are floating in space, all at rest with respect to John. And they all see the ship going by at some high speed V, as I've drawn it here. And they all agree that the light arrives at the position of Matthew before the position of Mark. And here's perhaps the more important thing, is you might think that one of these sets of observers, Matthew and Mark, or John and his friends, are really the correct observers. But there's really no way to objectively claim that the measurements of Matthew and Mark, who are on the ship, are more or less reliable than the measurements of John, who's watching the ship go by. This is because both of these sets of observers are in inertial reference frames. That is, they may assume that they themselves are at rest and the other people are in motion. And all of the observers see the light in a vacuum moving at speed c compared to themselves. Okay? So Matthew and Mark see the light emanating from this position in the center of the ship at speed c. So compared to them, it's traveling at the same speed to the left and to the right. That's precisely why they see it arriving at Matthew and Mark at the same time. John, who's outside of the ship, sees the light emanating from this point at speed c compared to himself. So he sees the light arrive at Matthew first and then at Mark second. And it's because he sees the speed of light at speed c compared to himself. Okay? So I'll let this sink in for a moment, and in my next lecture, what I'll do is I'll talk a bit more about the phenomenon of time dilation.